Hello everyone, I am Naveen Kumar. My roll number is 219558210 and I am from Aeronautical Engineering Section A from Institute of Aeronautical Engineering College. And the subject is thermodynamics. And coming to my topic, it is about thermodynamic analysis for supercritical carbon dioxide brayton cycle by considering both thermal efficiency and cooling area. Here I want to tell about thermodynamics. What is thermodynamics? Thermodynamics, it is a branch of science which deals with the heat and work. And the word itself indicating that thermo means heat and the dynamic means forces. And here the have choose a topic in the thermodynamics is thermodynamic analysis for supercritical carbon dioxide Breton cycle by considering both thermal efficiency and cooling area. Here the thermodynamic analysis for the by considering both thermal efficiency and cooling area on Breton cycle. And coming to this slide, the performance of supercritical carbon dioxide CO2 S is Breton cycle with the recuperator were investigated by the simulation method. Here the simulation means the method which is shows the difference between the prototype and model. Evaluation criteria were proposed for the system performance and optimization. The calculation and analysis of the system, thermal efficiency, and length of the cooler were performed. The effects of inlet and outlet of the expander. Here, the function of expander is to reduce the pressure and the heat transfer coefficient and logarithmic mean temperature difference. It is called as LMTD. And the software, on the system, the thermal efficiency and the length of the cooler were investigated. The system thermal efficiency as peak value with increasing of expander inlet pressure. Here the here the slide tells about the if the cooling area and pressure, what is the thermal efficiency. So about that this slides tell. And coming to this peak value, the peak value means the maximum value. The peak value varies from 45% to 45.4% with a different expander and outlet pressure. The average of heat transfer coefficient and the length of the cooler decreases with increasing of inlet pressure. But the LMTD is the one contrary when expander inlet pressure is the lower pressure stage 22 to in between the range of 22 to 26 megapascal. The thermal efficiency of the lower outlet pressure is 8 megapascal is higher, which ranges from 44.3% to 45.4%. However, the length of the cooler is also larger, 6.7 to 10.9 percentage. And these slides will tell us about what is the efficiency, was the peak value will be 45 to 45%. If we consider the pressure ranges from 22 to 26 and outlet pressure is in around 8 megapascal uh, and what is the it will use the efficiency in between the uh, 44.3% to 45.4%. And when we kept the length of the cooler is 6.7% to 10.9%. And as the expander inlet pressure is rises to the higher pressure range. So in before slide we have considered the expander pressure between 22 to 26 in around, and here we are considering inlet pressure of the expander is 26 to 30 megapascal. The higher outlet pressure same we have considered before slide, and here 95 megapascal 9.5 has greater advantages in thermal efficiency and and the range of efficiency is 44.57 to 45%. Similarly, the length of the cooler is largest 4.5 to 8 meters. Before both thermal efficiency, length of the cooler should be fully considered in the design of the system operating condition. Here we can say that the pressure inlet pressure is more than before slide. We have we we have see the difference in increase in thermal efficiency. If we have pressure is more, inlet pressure and the length of the cooler is less, and this gives information about that. And if you observe this diagram, it is uh, it is how the Brayton cycle, and the same principle here we can apply. The components are compressor, turbine, generator, pre-cooler, and recuperator and reactor. Here the main function of compressor. The main function of the compressor, you may all know aware about this, I think. So compressor is to increase the pressure and the temperature. After that, it will directly flows to the turbine, where, and the function of the turbine is to convert the what this gas, it is flowing energy into the mechanical work, and after that it will passes through the generator. The function of the generator is to convert the mechanical energy into the electrical energy to give the power. And if you see this pre-cooler, the function of pre-cooler is to cool when before going to compressor of what I say, a refrigerator or air. And the recuperator, it acts like a heat exchanger. Mm, it will extract the heat from the turbine, and it will directly send to the compressor, and it will extract the heat from the compressor, and it will directly send to the mm, what I say, turbine, and it will send to the reactor, and reactor will directly goes to, from reactor, the air or fluid, it will goes to the turbine. Coming to this diagram, here we can see the differences: low temperature recuperator and high temperature recuperator in the place of recuperator. And we have see the difference before that, recompression compressor. And it means that here we can see the recompression in the place of compressor. And coming to this lower temperature compressor recuperator, it works for the lower temperatures, and higher temperature recuperator, it works for the higher temperatures. And have the same diagram before that. And pre-cooler, we all know how to, what is the principle of pre-cooler and compressor and turbine, and this is the process how it will work. And coming to here, we can see the thermal process. Here we have seen that compressor and turbine, and high pressure carbon dioxide and low pressure carbon dioxide. Here the high pressure carbon dioxide, here heat insertion will be takes place, and the low pressure carbon dioxide, heat will be rejected from this process. This is a general process for all cycles. And coming to this temperature entropy, and we can call it as TS diagram also. Here the entropy means the process of, it is denoted with S, and the process of adding heat or removing heat to run the engine or what, for according to the requirement, it is called entropy. And the temperature means, I think you all know aware about this temperature. And here if you see this is the lines which is graph. Here these graphs, it is like parabolic shape, and there are T circuit means it is a T critical temperature, and P circuit means it is a pre-critical pressure. And the in this graph you can show, if you see that liquid region which is located left side of that, uh, left side, uh, and in middle we can see that In middle you can see that the liquid plus vapor region. Mm, and here the what is a gas region, and this is the area how the efficiency will be shown, and what is the efficiency, how it was increasing temperature and pressure, where it is varying, and this gives all about information. Here this is the critical temperature, and this is the critical pressure. And if you see if you observe that, here we can see the supercritical region. It is just above the critical temperature, and this is the critical temperature means the critical means the change in phase occurs here. The it will take the standard. And finally, thank you for listening my TED talk. Bye.